All right. I'm very excited about this unit that we're going to continue on with. This is the last week that we're going to spend on our climate and weather, but this week we're going to be spending some time engineering solutions to weather-related damages, okay? So we're going to be doing some engineering blueprints. We're going to hopefully be able to get in a STEM challenge this Friday, and you're going to be engineering solutions to weather-related issues. Now, if you've been at Indian Creek for any portion of time, hopefully you know what an engineer is because you all have engineered things before. However, if you have not, or if the pandemic has made you forget, or if you just have a bad memory like me and you forget, we're going to watch this quick video to review what an engineer is. What is an engineer?
How do we get around from place to place without having to walk everywhere? How can we communicate with people who live far away? These were problems that people struggled with for a long time, until recently, before there were things like cars and phones and computers. And you know who solved those problems? Engineers. But do you know what an engineer is? The short answer is that an engineer is someone who wants to know how and why things work. Now, I want to know how and why things work, but does that make me an engineer? Not quite. Besides being naturally curious, an engineer is a person who designs and builds things, like machines or systems or structures that help solve a specific problem. There's more than just one type of engineer, too. But no matter what type of engineer someone is, they have to ask themselves three very important questions when they're working. Number one, what is the problem that needs to be solved? And number two, who has the problem that needs to be solved? And most importantly, number three, why is this problem important to solve? Let's take a look at some examples. A really famous example of engineering is the Golden Gate Bridge in San Francisco, California. I mentioned that there are different kinds of engineers, and a civil engineer is someone who designs and constructs buildings, roads, and bridges. For the person who designed the Golden Gate Bridge, what was the problem that they needed to solve? People couldn't travel in or out of San Francisco, which is surrounded on most sides by water, without a boat. Who had the problem? Residents of San Francisco mostly, but really anybody traveling in the area. And why was the problem important to solve? Well, you didn't want a whole bunch of San Francisco residents trapped in San Francisco forever, even if it is a super cool city. Plus, you wanted people outside of San Francisco to be able to travel to the city easily if they needed to. So the Golden Gate Bridge was engineered as a solution to this problem. In addition to civil engineers, there are also mechanical, electrical, chemical, computer, nuclear, and software engineers, and the list goes on. Let's talk about what some of the other types of engineers do. First up, electrical engineers. Electrical engineers study electricity. They design electrical systems like circuits and computer chips. Think of an electrical object that you use pretty regularly. How about your microwave? What problem was the microwave a solution to? Cold food, right? You have an electrical engineer to thank for the ability to reheat that leftover pizza you just had for lunch. But while you might not have heard of Joseph Strauss or Percy Spencer, the engineers responsible for the Golden Gate Bridge and the microwave respectively, you've probably heard of Henry Ford. As in Ford cars? Henry Ford was a mechanical engineer, or someone working in the manufacturing industry, making mechanical things like tools, engines, and machines. Machines like cars. Ford didn't invent the automobile, but his Ford Motor Company made a lot of them. His Model T car was famous for being affordable for plenty of Americans. Ford saw that lots of people who wanted to drive cars just couldn't because they couldn't afford the pricey vehicles that were for sale. So he engineered a cheaper model as a solution to this problem. His fellow engineers started to do the same, and now, well, cars are everywhere. Henry Ford's not the only big-name engineer. A famous engineer around today is Marissa Mayer. Mayer is the president of the internet company Yahoo and is also a software engineer. Software engineers work on computers and other products that use software to write programs to make them faster and able to do more things. No matter what kind of engineer someone is, their job at its most basic level is problem solving. Each engineer just specializes in solving certain kinds of problems. While it might seem like there are too many types of engineers to keep track of, just wait 15 years, or 50, or 100, because we'll probably have a ton of different types to add to the list by then. Think about it. Over 100 years ago, we didn't have jobs in fields like aerospace engineering, where people design and construct planes and spacecraft. We didn't have planes like we do today, or need spaceships, so we didn't need people to engineer them. Who knows what machines or tools or everyday objects we'll have in the year 3015? Personally, I'm hoping for underwater cities. But whatever these things are, we'll need engineers to make them. So what do you say? Who wants to be an engineer?
Hopefully you do, because that is going to be our assignment and work today, okay? You today have an assignment, and that assignment appears here. And it says, let's engineer it. This week, you'll be engineering solutions to weather-related damages. Explore the different kinds of engineers by watching the video on instructional slide 1. We've just done that. Read about engineers by clicking the link on instructional slide 2. After reading, you're going to click this add response. You're going to use the label or microphone to record yourself explaining what an engineer is in your own word, or in your own, that's supposed to say in your own words. I said in your own problems. Draw yourself as an engineer. So as we're finishing, you're going to be drawing yourself as an engineer, okay? So as we read this book, I want for you to think about placing yourself here as the main character. How would you look as an engineer? Okay, let's take a look. When I grow up, I'll be an engineer. In the basement, Dad and I build a whole city out of blocks. Our city has roads, tunnels, and even an airport. Sometimes while we're building, I pretend I am Sunny, a real-life civil engineer. I design and build structures people use every day. I work for the city of Springville. My team and I are going to build a bridge to help people cross this river by car and foot. Engineering isn't just building things. First, there is planning. My team and I survey the land where the bridge will be built. We measure the land. We figure out where all the parts of a bridge could go. Once we know where the bridge will fit, we draw up the plans. I help the architect create a bridge that is sturdy and strong. We design a bridge that will safely hold the weight of the traffic. That's not all. Springville is a windy city. I use math and science skills to create a bridge design that can withstand high winds. We also want it to be beautiful. The architect creates a design that fits with the surrounding city. Next, my team and I choose what materials to use. We figure out how much we need and how much it will cost. Then we order the materials. We need to concrete and steel for our bridge. Finally, we are ready to start building. We need a lot of workers. A contractor hires a crew of construction workers. We give the bridge designs to the contractor. The crew starts on the foundation. I make sure they follow the plans. It takes months to build a bridge. We have to build the support piers and the flat decks. Workers build from each side. Now the bridge goes across the river. When the bridge is built, we are still not done. I run tests to make sure the bridge is safe and ready for traffic. I need to keep the people of Springville safe. Once I'm sure the bridge is built well and is safe, it's ready. People drive on it, and people can bike or walk across it too. I enjoy watching people use something that I helped build. When I grow up, I'll be a great engineer. But right now, my contractor, my dad, and I are having enough fun just pretending. All right. You right now are getting ready to create yourself as an engineer. Okay, so you are going to be designing how you look as an engineer. 1 second here. There we go. Okay, so if you would please on Seesaw, go ahead and click on your light bulb to refresh your feed. and you are going to see an activity called Let's Engineer It. Let's engineer it. We have watched the video and we have read the text together. Now you are getting ready to draw yourself as an engineer, and you are going to type or label yourself explaining what an engineer is. So here's how that looks. What is an engineer? You are going to type or record your answer to this question. You are also going to draw yourself as an engineer, okay? I'm gonna give us 8 minutes to get this done. So I'm gonna set you into a breakout room by yourself, and you're gonna take 8 minutes to record or type your answer to what is an engineer. And you are going to draw yourself as an engineer as well, okay? You have 8 minutes to get that done. There we go. Yes, Terrence, a question.
So, I'm not good at drawing.
That is quite all right, sir. We're all just going to do our best. All right, here you go. So I did not get to finish my drawing because, as you can see, I got a bald head and I'm not bald. So I'm actually going to be saving mine as a draft, but I wanted to share with you what I've gotten so far. So I put that an engineer is someone who works to solve problems in a way that will help others. Okay, that's what I understood as an engineer. Someone who will work to solve problems in a way that will help others. And then this is myself here. I am sitting down, I'm calling myself a schooling engineer because we have a problem of COVID and people needing to stay safe. And I've got to figure out how to teach you people in a way that helps you continue to grow and learn while staying safe. And we've never done this before, ever, in the history of Lawrence Township. So I am engineering solutions to these problems every day, okay? So I'm gonna save mine as a draft because I'm not done yet. I'm gonna save mine so that I can finish it later. If you're not done, I'm gonna ask that you do the same thing. Go ahead and click that orange check to draft it. You can finish this during independent work time. If you are done, go ahead and click that green check, okay? And that will save your work and turn it in. Excuse me. All right. Get you a minute to get that done because we're getting ready to move on to our official lesson for the day. So I'm gonna refresh here. Awesome. Either click check as a draft or check to turn it in. Camille, Justin, Motto, Sinq, John, either click draft or green check to turn it in. Yes, Terrence. As I shared with you, this week we are going to be engineering solutions to damages created by weather-related hazards, okay? So before we can engineer solutions to these, we've got to figure out what in the world is a weather-related hazard, okay? So that's what we're going to do today, is we're going to look at the impacts of weather-related hazards. Together as a class, we're going to review our success criteria and a question today. We're going to complete a Jamboard activity, and then we're going to watch a bit of a video. We're going to pause it and answer some questions, watch some more, pause it and answer questions, read a text and answer questions. All right. If you would please go ahead and click on that add response button. We're going to work on portions of this together, and then the rest will be completed independently. All right. Your learning target for today, as you pull up your response, is to develop solutions that could be implemented to reduce the impact of weather-related hazards. Okay. Today's question is, what is a weather hazard and how does it impact humans? So before we release you to engineer solutions to these, we've got to know what are they, okay? Let's take a look at slide 2 together. On slide 2, you will notice there are 3 questions. The first question is, what are some weather-related hazards? So if you would please, click on this link right here for Jamboard. What are some weather-related hazards? And this will open it up. You're not going to be able to write on it yet. I've got it locked. So just open it up. As you're opening it up, I'm going to read the directions.
And
Again,
have a
you're going to
ball.
slide 2 and you're going to click on your Jamboard, and I am going to unlock it for you. There you are. Now you can click on it. Okay. Slide 2, click on that Jamboard link, and here is what we are going to do. You are going to search Google Images for weather-related hazards. That's exactly what you're going to type in, weather-related hazards, okay? You are going to copy and paste an image of a weather-related hazard below, just one. And you will discuss the similarities and differences you notice about what has happened in these pictures. Complete a Google Images search for weather-related hazards. Copy and paste one picture. So I'm going to find one that I feel is helpful, like this right here. That looks like a pretty bad flood. I'm going to copy the image. I'm going to the Jamboard. I'm going to paste the image. I'm going to resize it so that other people can put their pictures. And then I'm going to leave it there. Okay? Go ahead and copy and paste your pictures. Okay, so it says discuss as a class similarities and differences you notice about what has happened in these pictures. So take a look at these photographs. What do you think is happening in these places where these disasters are happening? What do you think is happening to people's homes, to people's lives? What's going on here? William?
Bad things are happening to them.
Like what?
Like maybe the floods, wildfires, tornadoes,
What would
hurricanes.
those do?
Those will do a lot of damage.
Yeah,
Like
there's some damage going on. Aiden Hampton.
Tearing people's houses down and
Yep,
make it kill people.
they can. There's some damage to people's houses. There's some loss of life that's most likely happening. Levin?
It could really break. It can send people to the hospital.
Speak louder, baby.
It can send people to the hospital and they might
Yep,
not.
there's some injury that's happening. There's some people that are going to hospitals. Aiden G?
There could be a tornado that catches on fire. It could be a fire tornado.
There could be. What would that do?
So it might like burn down houses or trees or stores.
Nice. So there's going to be some damaging to different buildings, houses, some natural places like trees, some parks possibly, and stores. So I noticed that on here, there is damage being done by the wind, by water, by fire, be it through lightning or through wildfires. But there's lots of damage that's going to be happening using different weather, okay? You, as you know, are going to be working on fixing, preventing damage from these weather-related hazards, okay? Can humans stop weather hazards from happening? No, we cannot, okay? No matter how powerful we like to think we are, we cannot look at a tornado and say, stop, go away, and make it happen, okay? We can't look at a wildfire and snap our fingers and make it stop burning. So we cannot prevent weather hazards from happening, but we can do things that are going to help the damage not be as great, okay? An example would be like from our text where the school children made sandbags to build a wall to stop the floodwaters. They couldn't stop the flood from coming, but they could make it so that it wasn't going to be as dramatic of damage, okay? You're going to be engineering solutions just like that. Go ahead and move to slide 3. On slide 3, it says, name 2 ways that humans can reduce the damage caused from weather hazards. Name 2 ways humans can reduce the damage caused from weather hazards. We're going to get this information from a video. okay? At 3 minutes and 10 seconds, we're going to pause and we're going to write down what we heard about how we can reduce the damage caused by weather hazards, okay? So I will open up this video here and I want you to be listening. How can humans reduce the damage caused by weather hazards? Here we go.
Woo! It is raining cats and dogs out there.
They say cats land on their feet, so they should be fine. It's the dogs I'm a little worried about.
Relax, Bert. Raining cats and dogs simply means that it's raining really hard outside. It's a saying.
You humans are weird.
Dr. Jeff, are we safe in here?
Don't be such a scaredy cat. I was tying my shoe.
Right. To answer your question, Zoe, yes, we're perfectly safe. Engineers designed our lab to withstand all kinds of extreme weather.
Interesting. What kind of designs are we talking about?
I'm glad you asked. I'm Dr. Jeff Vineker, and today we're going to explore extreme weather solutions. Today, we'll learn that extreme weather is a result of natural processes. Humans can't stop extreme weather, but we can reduce its impact. And we'll see how engineers develop solutions to protect us from extreme weather. With Dr. Jeff. Welcome to Labracazam, where we make science make sense. So what do we mean when we talk about extreme weather?
Heavy wind?
Thunder and lightning?
Yes, and also floods, high winds, and heat waves. Extreme weather is any weather that falls outside the realm of normal patterns.
Like a tornado.
Or a hurricane?
Or bird poop. What? That stuff can get pretty extreme, let me tell you.
Extreme weather, not bird poop, causes a lot of damage.
Why don't we come up with ways to lessen the damage?
That's a great question. We can't actually stop extreme weather from happening, but we can reduce its impact.
All right, here we go. In the next minute, you're going to hear some ideas. Listen close.
Can we reduce the impact of extreme weather by trying to predict it?
Absolutely. By looking at past patterns of extreme weather, we know what regions on Earth are prone to different kinds of risks. For example, we know when it's hurricane season in the Atlantic Ocean by looking at patterns. Based on centuries worth of data, we know that the period between June 1st and November 30th of each year is when hurricanes are expected to develop across the Atlantic Ocean.
So each year, the people in the area near the coast can get prepared in case a hurricane happens?
That's right. How else can we reduce the impact of extreme weather?
What about coming up with new inventions and building methods to help lessen the damage?
Yes, we call those engineering solutions, and they help us reduce the effect of extreme weather. To take a closer look, let's break it down.
All right, we've just heard 2 ideas. Go ahead and go back to your seesaw. It says record your discoveries here. There were 2 ideas that we heard. The first idea goes back to our study on meteorology. We know that when we can predict weather, we know what to expect. So we can predict when and where bad weather will happen. So we can predict when and where bad weather will happen. Yes, William.
Never mind.
All
It was
right.
old.
The second way that we can reduce damage hazards is by what Izzy just said. Engineering solutions against damage. Okay, he gave several examples of engineering those solutions, such as buildings, making new buildings stronger, He also mentioned inventions that we can use to help us not experience as much damage. Okay. So 2 ways that humans can reduce damage caused from weather hazards. I'm going to go ahead and move forward. If you're not done, I've placed both answers in the chat. You can see them on the chat. On slide 4, it says that we are going to complete slides 4 through 5 as a class. Engineering solutions for coastlines, okay? You will see right here, it says coastlines, and there's a photograph that we can use to help us. This photograph is of a city that is on a coastline, a little town, okay? Coastline means land that is against water, all right? So water of some kind. Most often we call coastlines from the ocean, okay? We have a question. Name 2 ways that recurved seawalls protect against flooding. So we don't know what recurved seawalls are, but I bet we're going to learn by reading. And we're going to name 2 ways that they protect against flooding. I'm going to go ahead and add a text box here and put a 1 and a 2 because my directions told me to name 2 ways. So I'm just going to get myself ready to do that. 2 ways that recurved seawalls protect against flooding. Let's take a look together. Have your highlighter ready. If you'd like to, make it your favorite color. That way we can find our evidence and we will be able to name it quickly. Engineering solutions for coastlines. Coastal areas experience high waves from extreme weather events such as hurricanes. There are several techniques engineers use to protect coastal areas from flooding or erosion. Seawalls are concrete walls built along beaches that experience large waves. These physical barriers can block water and prevent flooding as water rises up from storms near the coast. So there's a way right there. They block water and prevent flooding. So that's one way. Seawalls with a curved surface known as recurved walls. Oh, look at that, recurved walls. I bet our answer is going to be here. Recurved walls not only block waves, but also send waves back out toward the ocean. Engineers have found that recurved walls are one of the more effective ways to reduce flooding on the coast. Another way to protect against flooding is to construct buildings on stilts or on top of garages to keep water from entering homes. And that's what we see here. All of these buildings are on top of wooden stilts, okay? Our directions asked us to list 2 ways that recurved seawalls protect against flooding. We just highlighted them in the text. The first way is they block water and prevent flooding. We kept reading and we saw that second statement that says they also send waves back out toward the ocean. So there are 2 ways that these recurved seawalls help protect against flooding. They don't allow the water in, and they also send the water back out. So it's kind of like a bounce back. The water bounces into the wall sends it back into the ocean, so it can't go onto the land. Okay? So this is one way that engineers have created a solution to flooding, to the damage caused by flooding, okay? They've moved these up, the buildings up, so that water can get under them. They've created walls in front of buildings so that when water hits, it hits the wall and not the building, okay? Two different engineered solutions that we've read about. I've placed those answers inside of the chat if you need them. We're going to move on to slide 5. Slide 5 asks us to watch the next 3 minutes and 10 seconds. As you're watching these 3 minutes, you are going to listen for this. What different types of solutions for flooding did the team test out with the water wave machine, and how was each designed to address the problem of flooding? Okay, so the team is going to come up with their own solutions, and how did they address the problem of flooding? All right, so let's watch this and think about what solutions you see.
This is a water wave machine.
So we can test the different ways of reducing flooding.
Exactly. Here's how it works. There's a paddle over here which moves up and down, and it makes waves that travel across the tank. Then over there, the water collects. It represents land, so we can test different solutions to flooding by comparing how much water is collected. First, let's see what happens with the tank in its current state. Here we go. What did we just observe?
The waves from the water spilled over, causing a flood.
Yes, they did. Let's measure the water to see how much spilled over.
Whoa, it's a little over 1,000 milliliters.
So that was a lot of flooding. Any solutions you could think of to prevent this from happening?
We could turn the wave machine off.
Yes. Anything else?
We could put up a barrier.
Perfect. We have a couple over there. Let's test them out. This barrier represents a high seawall. They're common on coastlines with really big waves. Let's see what happens this time.
Less water's going over, but it's still flooding.
Let's measure out the water so we can get a good comparison.
This one says 300 milliliters.
It's improved, but still a problem. What if we tried a different barrier?
I've seen these rocks along the coast.
That's right. They're similar to the big boulders we often see at beaches. Any predictions?
I think the rocks will stop the waves from flooding over.
I think the rocks will spread the waves, causing more flooding.
Let's find out.
They're blocking the waves.
That's right. Rocks like these slow down the speed of the water by spreading out the energy of those waves. Let's measure it and compare.
This says 100 milliliters.
So that's the best solution so far. Now let's try one more barrier. This is called a recurved wall, also commonly used on the coast.
Whoa, it's like a skateboard ramp, but for like, you know, waves. I predict that the wall is gonna prevent the waves from going over.
It's pretty short, so it'll probably still flood over.
Let's test it out.
It's blocking the waves, but it's also sending them back to where it came from.
Yes, the curved shape of the recurved wall prevents flooding by redirecting that water back out to sea. And it's the most effective way we've tested to reduce flooding on the coast. There are other solutions as well to reduce flooding. For example, constructing buildings in a special way to stand up to extreme weather.
When I visited Louisiana, I saw a whole town of houses on stilts. They built them high to keep rising water away.
There are also homes built on top of their garages. Better the car gets soaked than the whole house.
All right, so let's take a look. We just saw 3 different solutions. What different types of solutions for flooding did the team test out with water wave machine, and how was each designed to address the problem of flooding? Okay, we've got 3 things to type here. Our first solution that we saw was the higher seawall. So a taller seawall. Taller seawall blocks bigger waves. Again, I will place that in the chat since we had so much to accomplish today. We've got to move a little bit faster. So a taller seawall will block the bigger waves. Okay, we saw that that did help keep some of the water out, but there was still quite a bit of flooding that occurred. Our second solution was to add rocks. So when we added those groups of rocks, it said that it broke up the energy of the wave. So rather than the wave just continuing to flow, the wave hit the rocks and it slowed the wave down. So groups of rocks slow the waves down. Okay, when waves are slowed down, they aren't able to fly as high and create as big of water overflow. William.
Because the rock spreads out the waves.
Yes, it spreads out the energy of the waves. So there's a lot of energy. They're super high, they're super low, they're super high, they're super low. They hit the rocks and it kind of slows it down. Okay, just like hitting a curb in a car slows it down as well. It breaks down that energy. Aiden Hampton.
It stops their energy.
It does. It stops their energy. That is correct. Our final solution, solution 3, was what we just read about on the previous text, and that was called a recurved seawall. And the recurved seawall sends the waves back. Sends them back into the ocean where they came from. Okay, now we know from our video that the recurved seawall worked best. Okay, we know that it worked best because it actually combines both of the previous solutions. Okay, it blocks the waves, but it also slows the waves down by turning them back on themselves. So if I'm going full speed and I hit something, I've got to go back. I bounce off and slow down and go back to where I came from. So which solution was the best? The recurved seawall was best because it's blocked the waves and turned them around. The recurved seawall was best because it blocked those waves and it turned them around. Okay, again, that is in the chat. Slides 6 through 9 are supposed to be completed with a partner. Okay, we got a little bit behind today on completing these with a partner. So I'm going to give you a choice. I am going to stay here and let you work with partners. Or if you feel like you can handle it by yourself, you're going to be able to log off. Okay, but before you do, I need to go over the expectations. So slides 6 through 9 are like what we've just done. We're going to read about a solution for high winds. We're going to watch a solution for high winds. We're going to read about a solution for lightning. We're going to watch a solution for lightning. Okay. Then on slide 10, the independent work is to watch the rest of the video and to draw a house and label features that may help it withstand flooding and lightning. So this is not you going like this and clicking the check. It says that you're going to draw a house and label features. Okay, that means that you are going to add engineered designs to the house that are going to help it with flooding and lightning. So you're going to add text box labels around your drawing telling me what they are. Okay. All right. So this is going to be your independent work. We will be back together at 10:30. If you would like to stay on and complete slides 6 through 9 with partners, I'm going to send you into some breakout rooms to do that. If you want to do slides 6 through 9 by yourself, you can log off. Make your choice and I will get those rooms set up for you.